So here we have our errors to see code in our traffic analyzer project. We have these two models here. So we have this method here there that will be called to discover the congestion network level. We have this one here in the MLP. We have something similar, and this method here, we have a sign here that you see when execute the simulation to compare the throughputs. We are going to talk about this illustration of our paper. So the models placed in our traffic analyzer. The traffic analyzer will pass the features to the model, exported using Keras2C, as we have shown in previous videos, and you use the output of these models to update its congestion window. Okay, so let's execute. So to execute, we have to configure our configuration file. We will execute the simulations regarding throughput gains as placed in our article. So we have to put the time 15 minutes to the simulation. This Vegas is the one that we can activate the intelligent congestion control. So we have to set this parameter to 1 here. The others, we have no train, we have no generalization data. We are with throughput evaluation. So we have throughput evaluation here with 1 here. And this is the parameter that tells to traffic analyzer that we have intelligent congestion control. And this is the architecture. 0 is the MLP with three features, accent and RTT. The bear 5 times 10 powered to -5. Okay, as we can see here, and let's execute. I have a script that I've prepared to do that. This script prepared to execute the NS3 simulation that will produce a XML file using its flow monitor model. And I will show you this mechanism here. Let's go ahead here. Okay, so here we have some outputs here, but nothing. It's important to see that we have MLP with when we have no features, it means that we have the 3 features. Okay, the full name here. Let's press. Here we have our error. Let's go ahead. Here we have some outputs indicating that we have intelligent congestion control in this node here, node 7, node 8. We have a simulation with 20, 20 transmitters, we have 20 flows, so 20 transmitters, 20 receivers. So each one. So that's the simulation. We can see sometimes where the the congestion window increase, where congestion will decrease, as you can see here. And here we have the sign showing that the model the model is working, is outputting, okay, its provision to the intelligent congestion control. In the end of this simulation, we have the XML file here. This file is entirely generated by Flow Monitor. We don't touch in its content, and we have to copy it to our experiment folder. Remember, in our notebook, we are connected here to our driver. So remember, this is our experiment folder. Let's go inside and let's create a new folder here. Flow Monitor. Let's create another folder here. Let's wait. We have to create a folder for each one of our congestion control type. Let's start with the one that is assisted by MLP with FM and RTT. Okay, so here we have our folder, and we have we will cut the file generated by the simulation here. And you see here, and let's put it into this folder here. So okay, what we're going to see, let's put this folding is not strictly necessary, but if someone wants to check, let's put here. Okay, so here we have, but the important file is this one here. So we have simulation for 20 flows using the intelligent congestion control assisted by MLP using the three features accent and RTT. So let's go ahead to our simulation. Let's change. We have now to do one for 40 flows. Okay, so we are going to our terminal. Let's go to another tab here and let's execute. We will see that that some difference because we have now 40 flows. So here we have the same model. So here you can see that we have from 0 to 39, it's 40 flows. Again, our bottleneck height, okay, and our bear. Let's go ahead. So you can see that we will have 40 intelligent nodes. 0 from 39, and execution is very similar, output is very similar to the one here, to the last one we have made. So It's good. It's the same. So we are going to get the corresponding file. Here we have the corresponding file. Let's go to the corresponding folder in our drive. Okay, and let's take its parameters. Its parameters too. Let's go to the 60 S. Let's go to our terminal. New tab here. While run. Okay. Again, MLP again. Again, the same error, same bottleneck rate. This is the last one. So we have our simulation here. Okay, executing here. Okay, this is the end. Let's go to our output file here. Here we have the XML file, the corresponding XML file. And let's go to our information, folder. It's there too. Let's go ahead. The last one, 80 flows. Let's go again. Let's new time here. Oops. Let's run our simulation. Again, our MLP. Okay. Here you can see that we have 80 senders, 80 receivers. 9. Okay, the last one. Okay, there he goes. Okay, here we have our the file output by floor monitor. Let's go up. Let's get the information. Simulation, configure, information. Let's put here true. And that's all for the congestion control system by MLP with the 3 features. Let's be here. We have the XML files. We have the XML files that we will use to generate our graphs. Which graphs? These graphs here. These tables. These tables and these graphs here present in our article. Okay, so I will generate the other files, I will execute the other simulations behind the scenes. We will be back, okay, in our notebook.